This is going to be a demo on how to use Sage. So let's take a look. So let's suppose the motivator is I'm going to try to graph the intersection of x squared plus y squared equals 1 and the plane x plus z equals 3. Well, to do that, I'm going to go up to, I need to use NX. So go up to academic software, computer science, NX. That's going to link you to a Linux computer. And so your login is your normal CSBSJU username, except all lowercase. And then your password is going to be the last 4 letters or digits of your student ID. So it could be 1, 2, 3, 4, and then the last 4 letters, first 4 letters of your username right there. So I already have a password, so I'm going to use that instead. But if you don't have a password, that's what it is the last 4 letters, last 4 digits and first 4 letters. And then we'll just wait until it pops up, and it will. Okay, so let's take a look and see what happens. I'm going to click on terminal here, and the command is \, or just /opt sage. If you don't remember, just hit enter, hit tab. If you hit tab, those options will come up. You want 4.1, and you can hit 4 and then tab, and then just type sage again. That's going to cause it to come up and work. Now I want you to type notebook, parenthesis, like that. And a browser will come up with a notebook. Click on new worksheet. And now we're actually going to do stuff. 305 video demo. Alright, so we're going to do this. The first thing I want you to do is define your variables. And you do that by typing in exactly what I'm typing in. And then you evaluate them. Oops. That's because it's supposed to be there, I bet. I always get that wrong. Okay, so what are we trying to do? We're trying to plot this. We're trying to plot these two. Well, there's a good way of plotting these. If you do implicit plot 3D, and then here's the catch. If I want to graph this, what I need to do is I need to get one side of the equation equal to 0. So this goes to x squared plus y squared minus 1 equals 0. And I'm just going to enter on the other side. X squared plus y squared minus 1. And then I need to tell it what the bounds are. X will go from -2 to 2. Y will go from -2 to 2. And z will go from -2 to 2. So I'll just copy and change these. If I evaluate, now I get a graph, and I can grab it. Hey, look, I can spin it around, and there I have a good graph. But remember, the original problem is I was supposed to graph the intersection. Well, I can do this very similarly by doing the same deal. I can get x plus z minus 3 is equal to 0. And if you want to graph both of them, what you can do is you can just take this thing and multiply it by the other. Because what it's doing is it's evaluating where whatever you put in here equals 0. If I multiply two things together, the product equals 0 when either of them equals 0. X plus z minus 3. Click evaluate. And now I get the intersection. This was not the best example. So I need to go up a little bit higher, so let's do that. Let's raise the z value. Change z to 5. Oh, now we can see how this intersects. You can kind of visualize what's going on. I get kind of an ellipse type thing. Alright, so I'm going to show you one other way of graphing them. Let's look at contour plots. Here we can just enter in a function, say x plus y squared. And again, we're just going to plot, I need to tell it what the x's and y should do. So I'll do this, contour plot, and it'll evaluate x plus y squared. Here are the contours. And if you want to add labels, you can just do labels equals true.